Now we're recording. Okay. So we'll be graphing quadratic functions, and the graph of a quadratic function is called a parabola, as you see there on the paper. Okay. And our quadratic functions are of the form f of x equals ax squared plus bx plus c, where the leading coefficient a cannot be equal to 0. And let's go ahead and see the characteristics of the graph of a quadratic function, or the characteristics of a parabola. Okay, so what does this say? For each parabola, label the following: vertex, axis, symmetry, y-intercept, x-intercepts, and max or min. Okay, so I'm gonna zoom in a little bit more on these. There we go. Okay, so what we are seeing first is a parabola that opens up. So this is a parabola that opens up. Both tails head towards infinity. Okay, so on a parabola, there is a main point, and that point is called the vertex. So that is the very middle of the parabola. So that's going to be right here, the middle point of your parabola. That is called the vertex. And the vertex is always given as a point H, K. It's also known as X and Y, but to separate the vertex from everything else, we label the vertex as HK. Okay, and then the line that cuts straight through your parabola, so there is a line that cuts straight through your parabola, and that line is called the axis of symmetry. So this is called the axis of symmetry. Okay, and then since this parabola opens up and crosses the x-axis, if you cross the x-axis, then right where you cross happens to be x-intercepts. So there's an x-intercept, and there's an x-intercept. Okay. And then the other thing, what do we have? Intercepts and max or minimums. Okay, so next is your y-intercept, but since our vertex is right on the y-axis, it's also going to be known as the y-intercept. Now, this is not always the case. It's just with the parabola we're given here. So the vertex here is also going to be our y-intercept. Okay. And then, since this parabola opens up, it creates a low point. And this low point is called a minimum. So whether your parabola opens up or down, the vertex is always also going to be considered a minimum or a maximum. So in this case, since we open up, the vertex is going to be considered a minimum. Okay. Can you hear me now, Barbara? Maybe. All right. Everybody else can hear me, right? Yes? No? Maybe? Good?
Yes,
Done?
I can hear you.
All right. All right. Good. All right. Okay. So these are all the pieces of our parabola, and this is a parabola again.
Okay, I think I got you now.
All right, perfect. This is a parabola that opens up. All right, good. All right. And now let's label the other one. So the other parabola is a parabola that opens down. So again, the top part, the main point, the middle point of your parabola, that is your vertex. And then again, the line that cuts straight through the vertex and through the middle of your parabola is your axis of symmetry. And then since this opens down and we cross the x-axis, we intersect it twice. So these again are the x-intercepts. And it does not show the graph intersecting the y-axis, but eventually the graph would intersect the y-axis and give us a y-intercept. But with the portion of the graph we're given, we can't label a y-intercept. Okay. And then the last part, maximum or minimum. Since this graph opens down, since this parabola opens down, the vertex is also going to be considered a maximum. So this is going to be a maximum. All right. So intercepts, vertex, intercept. Yeah. Maximum axis of symmetry. And this is a parabola that opens down. Okay. So let's get into domain and range of quadratic functions. So let's start with a parabola that opens up. The domain, well, first off, here's the easy part. The domain for any quadratic function, and remember, domain deals with x values. The domain for any quadratic function is a set of all real numbers. These parabolas go on from negative infinity to infinity. So the domain of any quadratic function, any parabola, is negative infinity to infinity. The range, which deals with the y values, well, for a parabola that opens up, the range will start at the y value of the vertex. Now remember, the y value of the vertex is represented by k. So if a parabola that opens up, your range will start at the y value, which is k. And since you start at the vertex, your tails will head towards infinity. So your range starts at k and heads towards infinity. Okay, so that's for a parabola that opens up. Now, a parabola that opens down, well, guess what? Your domain is still all real numbers, negative infinity to infinity. But now your range, since these tails are headed towards negative infinity, we must start at negative infinity. And then we come up the y-axis and we have to stop at the y value of the vertex, which again is represented by k. All right. And those are all the characteristics of parabolas. A parabola that opens up, a parabola that opens down. One thing I did not mention is our parabolas may have 2 x-intercepts, 1 x-intercept, or no x-intercept. It just depends on the equation. So a parabola can have 2 x-intercepts, 1 x-intercepts, or no x-intercepts at all. It will always, always, always have a y-intercept though.
I'm going to feel like I'm going to do something wrong now if I don't see like an x-intercept.
Don't worry. We can always use Desmos to check our parabolas. Okay, so everybody good with this? Yeah, got a thumb, all right. Cool, okay. So now, just more characteristics about the quadratic functions and the parabolas. So a parabola opens up if, so what I'm gonna do for this is rewrite our quadratic function again. F of x equals ax squared plus bx plus c. A parabola will only open upwards if the leading coefficient a is positive. So we say if a is greater than 0, that means a is positive. And a parabola will only open down if a is negative, less than 0. All right. The axis of symmetry is given by the equation. Since it's a vertical line, it's going to be x equals, and what's cool about this is that the axis of symmetry is equal to the h value, which is the x value of the vertex. So the axis of symmetry is equal to x equals h. So whatever that h value is of your vertex, that is the value for your axis of symmetry. They go hand in hand. Okay. And now, to find the vertex, we use a special formula. And that formula is given by h equals negative b over 2a, and k is equal to f of h. So that is how we are going to find the vertex of these parabolas. We will use this formula. We will first find h, and then we will find k. All right. And then to find a y-intercept, we know how to do this. To find a y-intercept, you let x equal 0. That's how you find an y-intercept. You let x equal 0. Okay. Let's say let x equal 0. Solve for y. Okay. And then this says, sketch 3 different examples of a parabola that has 2 x-intercepts, 1 x-intercepts, and no x-intercepts. Okay. So, oops. There we go. So if I have 2 x-intercepts, this means my parabola crosses the x-axis twice. So an example of that would be an example of the ones we had above. And I'll just do a small little sketch like it says. If I have a parabola that has 2 x-intercepts, this means that I cross the x-axis twice. So here would be my 2 x-intercepts. Okay. And now, if I only have a parabola with 1 x-intercept, this is what we look like. I will come down or up, whichever. Let's go the other way. We'll say we will come this way. I come up. I only touch the x-axis once, and I come down. And right there would be my 1 x-intercept. Of course, there's other models for this. I can even have a parabola that opens up, touches, and then goes, and that would be 1 x-intercept as well. Okay. And then last, a parabola that has no x-intercepts. Well, will look like this. I will say, let's just open up, and it's just floating somewhere in one of the quadrants. So the same could be said. I could have a parabola that opens down, doesn't touch it, or I have another parabola that opens down over here, or a parabola that opens up over there. As long as you don't touch the x-axis, those are parabolas with no x-intercepts. Okay, there you go. So just like I said, parabolas may have 2 x-intercepts, 1 x-intercept, or no x-intercepts. Okay. It all depends, again, on the equation. All right. Now, what's this say? Find the x-intercepts. We know to find x-intercepts, we let y equal 0, and we solve for x. But apparently, we are not going to be finding x-intercepts in this lesson. I think we'll do it in another lecture. Okay. So domain and range for parabolas, we already figured that out above. So I'm going to say C, graphs above. So remember, we already found domain and range up here. So if you haven't written it down yet, please do. Okay. Everybody good with this first page? It was all definition. Everything we need to know about parabolas and quadratic functions. Okay. Let's get moving. All right. So, A, use the vertex and whether the graph opens up or down to determine the number of X-intercepts and sketch the graph. Okay, so this means I'm gonna need more space. So I'm gonna use the right side over here. And that's perfect. Okay, so let's start with 1. I'm just gonna rewrite the function. F of x equals x squared plus 5x plus 4. And one thing to remember is we are comparing all of these to the standard quadratic function. All right, so the first thing we want to know is, does this parabola open up or open down? And to know that, we need to know what is the leading coefficient. So for our function x squared plus 5x plus 4, what is the coefficient on this x squared?
4. Nope.
The coefficient, what is the number in front of that x?
1, positive 1.
Good. A is 1. And is that a positive number?
Yes.
Yes. So since that is a positive 1, this means our parabola will open up. Okay. So now we know our parabola is going to open up. And the next thing we need to find is the main point of our parabola, and we are going to be looking for the vertex. So we are also going to be using this formula to find the vertex. H equals negative b over 2a, and k equals f of h. This is the vertex formula. Okay. Now, label A and B. So we already have A labeled. A is 1. What is the value of B on this function?
5.
5, right? Remember, we are comparing it to the standard form above. So A is 1 and B is 5. And all you need to know is A and B in order to find the H value of our vertex. So let's go ahead and do that. So we'll have that H is equal to, and I'll rewrite the formula, negative B over 2A. And now I'm going to plug in B. So it's going to give me negative 5 over 2 times A, which is 1. So here we get negative 5 over 2, which is negative 2.5. So there is the H value of our vertex. Okay. Now, to find K, we are going to take negative 2.5 and plug it in to this function for every x. So to find K, we're going to say f of negative 2.5 and plug it in for all our x values. Negative 2.5 squared plus 5 times negative 2.5 plus 4. All right, and calculate. Where are my calculators? Over there. I'll just use Desmos. Let's see. Browser. Boom. And if somebody has it already, shout out that answer. Why not? And make sure you're typing it in your calculator just like I wrote it with all those parentheses. And we get negative 2.25. Was that right? There we go. Let me do something real fast. I just need that browser. Perfect. And perfect. Nope. And that needs to go over there. Cool. All right. Negative 2.25. So this means that our vertex on the graph is at negative 2.5, comma, negative 2.25. So this one said to sketch it. So let's just draw a little graph here. Doesn't have to be perfect. And we just have to plot the vertex and yeah, and just go by how it opens. Okay, so for my labeling, let's see. I'm at negative 2.5 for my X values. So I'm gonna make that negative 1, 2, 3. So there's negative 3, there's negative 1 and negative 2. And then we go down to negative 2.25. So negative 1, negative 2, negative 3. Okay, so my vertex is at negative 2.5 and negative 2.25. So I'm just gonna put it right there. There's my vertex. And since our parabola opens up, I am going to cross the x-axis twice. So we see that we have how many x-intercepts?
2.
2. 2.
Professor, do you mind repeating that where you graphed the first point?
Okay, cool. I mean, they're not actual points, but oh, sorry, this one, right? The vertex. So graphing the vertex, we are using what we found above, H and K. So it's just a sketch. It doesn't have to be perfect. So to plot negative 2.5 and negative 2.25, I go to the left, negative 2.5 spaces, and I go down negative 2.25 spaces on our graph. And then from there, after I plot the vertex, we know that the parabola opens up. And if I open up from the vertex, I'm going to cross the x-axis twice.
Thank you, got it.
Yeah. All right. Any other questions on that one?
Where'd you get to negative 5?
From the formula. So the formula is negative b over 2a. So what was our b value from that equation?
Oh, okay. So where the number is for b, it's going to be a negative number.
Exactly. Unless b is negative, then it'll turn positive.
Okay.
Yeah, good. Good question. All right. Everyone good with this one? All right. Cool. 2 thumbs. Perfect. Don't worry. More practice, right? Like this is all brand new to me. Okay. Let's do number 2. F of x equals x squared minus 3x plus 10. So I'll just come out here. X squared minus 3x plus 10. Cool.
Wait, I'm so sorry. What is the K? What is the K? Is it?
K is the y value of the vertex.
Oh, okay. Thank you.
Mm-hmm. All right. X squared minus 3x plus 10, right? Yep. X squared minus 3x plus 10. Yeah. So remember, for your vertex, you can also see it as x, y. The reason we don't label it x, y is so we can have the vertex stand out as its own point. That's why we say HK is our vertex.
Thank you.
Okay. And then x squared minus 3x plus 10. And here, do it again. So compare it to our standard form. And what is the value of A?
1.
1, which is positive, which means we open up again. And then what is the value of B?
-3.
-3.
3.
And that's all we need to know to find the vertex. So now we move on to finding the vertex, and H equals, and I'm just going to write the formula again. The more I do it, the more it burns into your brain. And you'll have negative times -3 over 2 times A. This gives us positive 3 over 2, which is 1.5. There's the H value of your vertex. And once again, you're going to take that H value, 1.5, and plug it into the original function for every x. So K equals f of 1.5, and you will get 1.5 squared minus 3 times 1.5 plus 10. And type it in just like I wrote it. 1.5 squared minus 3 times 1.5 plus 10. And we get that our K value is 7.75. Okay, we have found our vertex. My vertex is at 1.5 and 7.75. Such ugly numbers. Draw our sketch, doesn't have to be perfect. And I am at 1.5 on the x-axis. So there's 0, there's 1, and there's 2. So there's 1 and 2. And then I'm at 7.75 on the y-axis. So I'm just going to go up to 8. 1, 2, 3, 4, 5, 6, 7, and 8. There's 8. Okay. And then my vertex is plotted at 1.5. So you go to the right 1.5 spaces, and you go up to 7.75, which is right below 8. And there's my vertex. Okay, and since it opens up, well, I need more room, right? Because now, since this opens up, it's going to open up and to the left, up and to the right. But let's see if I can drop that down. Let's go, computer. There we go. Good enough. Okay. So now that'll open up and up. And do we touch the x-axis at all?
No.
No. So there are no x-intercepts. All right, cool. Okay. Any questions on that one? Everybody good? Okay. All right, number 3. Well, we got negative x squared plus 10x minus 25. So let me write that real fast. Negative x squared plus 10x minus 25. Okay. back over, scroll down, and let's label our value of A. What is the value of A?
-1.
-1. Good. So A is -1, which means we will open which way now?
Down.
Down. Good. What's the value of B?
10. -10.
10. Just 10. Positive 10. It will become negative with the formula. H equals -B over 2A. And this gives me -10 over 2 times A, which is -1. You get -10 over -2. And this gives me 5. So there's the H value of our vertex. Okay. And then K, we take 5, plug it into the function, and you get negative parentheses 5 squared plus 10 times 5 minus 25. Let's see what we get. So -5 squared. Make sure that negative's outside of your parentheses. Plus 10 times 5 minus 25. And we get 0. Okay. Which means we now have our vertex. Our vertex is at 5, 0. Okay. And now let's sketch our graph. So I'm only at 5, 0. So that's right on the x-axis. So I'm going to go out 0, 1, 2, 3, 4, 5. And right at 5, 0 is my vertex. And since our parabola opens down from the vertex, I go down to the left, down to the right. And since it's right on the x-axis, how many x-intercepts do I have?
1.
1.
1 x-intercept. Oh. There you go. Cool. All right. Everyone good with that? Okay. Sweet. I don't think I need Desmos anymore. We'll see. We'll see. All right. So there's that. Okay. So now we are given the graph of a parabola and we have to answer the questions below. All right. So for graph A, I guess we'll just focus on graph A. So all of these questions for graph A right now. Okay. It says, what is the axis of symmetry for the graph of A? So let me zoom in. There we go. So what is the axis of symmetry for the graph of A? Remember, the axis of symmetry is the line that cuts straight through the middle. So that line cuts straight through what x value?
3.
3. Good. So our axis of symmetry is going to be x equals 3. And then the next question says, what is the vertex of this graph? Remember, the vertex is the main point, that middle point on our parabola. So what is this vertex? What are the coordinates?
3 and 4.
Good. 3, comma, 4. So our vertex is 3, comma, 4. Okay. And if you need help seeing that, well, here's 3. You go up and you match that y value to it. So 3, comma, 4. Okay. And then does this vertex give a maximum or a minimum? Since it opens down, it creates a high point, which makes it a what?
Maximum.
A maximum. Good. So this gives us a maximum. I'll even label it up here. So this is also a maximum. Okay. And then identify the domain and range of the graph. So lucky for us, what is the domain of all parabolas?
Negative infinity. Infinity?
Yep, negative infinity to infinity. All right. And since this parabola opens down, these tails are headed towards where?
Negative infinity.
Negative infinity. So we start at negative infinity and we come up the y-axis and we have to stop at the y value of the vertex. What is the y value of the vertex?
4.
4. And it's included, hence the bracket. Okay, there's our domain and range. I'll say on graph. All right, identify the y-intercepts. All right, so looking at this graph, what do you think our y-intercept is?
Negative 5.
Negative 5, we'll say it's right here. Our y-intercept is at negative 5. Okay, cool. So 0, negative 5. Explain how 6, negative 5 is related to our answer for 5. So how is 6, negative 5 related to this, to the y-intercept? So let's go ahead and plot 6, negative 5 and see where that puts us. So 6, negative 5, right there. So how or why are these points related?
It's right across from the y-intercept on the parabola.
Say that again.
It's right across the y-intercept on the parabola.
It's right across, but let's go into more detail on that. It has to do with that line that cuts right through. So yes, these points are right across from each other, but not only are they right across, are they the same distance?
They're symmetrical?
Yeah. These points can be reflected across the axis of symmetry. So they reflect over the axis of symmetry. So that's what's great about the axis of symmetry is you can reflect points over it and they will be the same distance, or fancy word, equidistant from each other. So look at this. This is 1, 2, 3 spaces from the axis of symmetry. And this point is also 1, 2, 3 spaces from the axis of symmetry. So that's how those points are special or related. So I guess we'll write that down there. We'll say they are equidistant from each other. Or not from each other, but from the axis of symmetry. Ha. Axis of symmetry. Boom. Okay, cool. All right, that's everything for graph A. Now let's do it for graph B. All right, so graph B, let's focus on you. What is our axis of symmetry for graph B?
-5.
Do we have different graphs? So what's our axis of symmetry? X equals what?
-2.
2.
X equals -2.
Backwards.
I was like, don't tell me you have different graphs.
No, I did. Saying and doing things backwards again.
All right. And what is our vertex? What is this main point?
-2, -5.
-2, and is that, yeah, 1, 2, 3, 4, 5. Good. -2, -5. So -2, -5. All right. And then do we have a maximum or a minimum?
Maximum.
Since it opens up, it creates
Minimum.
a low point, which is a
Minimum.
minimum.
-5.
All right. Good, good. And we're going to say on graph for that one. Okay. So we want the domain and range. And once again, lucky us. What is the domain for all of these functions?
-infinity to infinity.
-infinity to infinity. And now our range, since we open up, we start at the y value of the vertex. So we start at -5. And where are these tails headed?
Infinity.
Infinity. Sweet. Okay. And then what's the next question? Y-intercept. Good. Where's our Y-intercept at?
I'd say -1.
-1. Perfect. 0, -1. And that's our Y-intercept. And the next question I think I saw says, how is this point -4, -1 related? What do you guys think? Are they the same distance from the axis of symmetry?
Yes.
Yeah, that's it. You can reflect them over. That's it. So bam. That answer goes there too. Okay.
So we could just put that they're symmetrical.
Yeah, that's fine. Lots of words. They are symmetrical over the axis of symmetry, which is symmetric. All right. Woohoo. Everyone go with that page? Okay. All right. Now we will practice graphing. More graphing. Yeehaw. Okay. Cool. Sketch the graph and identify the following characteristics for each function. All right. Cool. So just to write it again, remember we are comparing these to the standard form, which is ax squared plus bx plus c. And now we want to know, do we open up or open down? And to know that, we need to know the value of a. What's the value of a?
1.
1. That is positive, so we will open
Up.
Up. Perfect. And then in order to find the axis of symmetry and the vertex, well, we actually need to find the vertex first. So let's go ahead and label B. And what is the value of B?
-6.
Good. -6. Now let's find that vertex, which will find the axis of symmetry for us. Okay. So here we'll say H equals -b/2a, and you'll get -6/2 times 1, which gives us 6/2, which gives us 3. All right. So there's the H value for our vertex. And now we need to find K, which means you will take 3, plug it back into the function above, and that'll give you 3 squared minus 6 times 3 plus 13. All right. What is that? 9 minus 18, which is -9, and -9 plus 13. That gives me 4. Somebody double check that. Okay. So there's our vertex. So we'll be at 3, 4. And now remember, if you have the H value for your vertex, you have the same value for your axis of symmetry. Okay, sweet. And now we want to find a Y-intercept. All right, how do we find a Y-intercept? We let X equal what number?
0.
0, good. So to find a Y-intercept, we let X equal 0, which means we take 0 and we plug it in for every X into the original function. So you'll have F of 0, which equals 0 squared minus 6 times 0 plus 13. And you get 0 minus 0 plus 13. So F of 0 is equal to 13. And there's our Y-intercept at 0, 13. And now the rest, the number of intercepts, domain, and range, we will figure out by graphing this function. So go ahead and plot your vertex first. So vertex is at 3, 4. So here's 3 and there's 4. So go to the right 3, up 4. Here is our vertex. Okay. And then we have a Y-intercept at 13. That's not gonna fit, but we have room. Why not? We'll just say that that's 11, that's 12, there's 13. And I will plot my Y-intercept there. Okay. And now, since we know the parabola opens up, I will open up into the right. Oh, I want fun colors. Let's see. There we go. Up and to the right and up and to the left. Sorry, shouldn't be so ugly. Going through that Y-intercept. Maybe I can make it prettier. Let's see. Doubtful, but maybe. Ooh, look at that. All right. Cool. Now we can answer the last 3 questions. Do we cross the x-axis?
No.
No.
So how many x-intercepts do we have?
0.
0, none, 0. And what is the domain of these type of functions? negative,
Infinity and infinity.
and infinity. And the range, since it opens up, it starts at the y value of our vertex. What's our y value?
Four.
And we head towards
Infinity.
There you go. Cool. And I know it doesn't ask, but is this a max or a minimum?
Minimum.
Minimum. There you go. Cool. And that's it. That's all it wants. All right. Not bad. Try not to jumble everything on the next one. There we go. All right, everybody good with that one? Okay, let's do it again. All right, let me see. Dun, 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 dun. Perfect. Okay, cool. So here we go again. F of x equals negative x squared minus 2x minus 1. What is the value of a here?
1.
1 or
Negative
-1.
one.
-1, which means we will open
Down.
down. What's the value of b? Don't forget
-2.
your
Negative
negative.
2.
I hate them things.
All right. So now we can find h and k. So we'll say h equals negative b over 2a, and that'll give you negative 2 over 2 times -1. And that'll become positive 2 over -2, which gives us -1. So our h value is -1. Okay. And then to find k, you do f of -1 and plug -1 into the function above for every x. So you're going to have -1 squared minus 2 times -1 minus 1. All those negatives. Let's see what that becomes. That stays -1 squared is 1, but it's negative. And -2 times -1 becomes +2. So you get -1 plus 2, which is 1. And 1 minus 1, we get 0. There we go. I'll box those up. So our vertex is at -1, 0, and our axis of symmetry is at x equals -1. Okay. And now we need to find the y-intercept, where we let x equals 0, plug it into the original function. And if I plug in 0, that becomes 0, that becomes 0, and what am I left with?
-1.
-1. So we get our y-intercept at 0, -1, which is coming right over here. 0, -1. Okay, we have enough information to plot this graph. So let's go ahead and put our vertex down, which is at -1, 0, right here. -1, 0. So there's my vertex. And then we'll plot my y-intercept, which is at 0, -1. There's my y-intercept. Okay. Oh yeah, and if you want to accurately graph this, not like the one above, we can use that axis of symmetry to reflect the y-intercept across it. So if this y-intercept is one space away from the axis of symmetry, then another point would be one space to the left. And now we have everything we need. Go down and to the left, down and to the right. Okay. And now we can answer the remaining questions. How many x-intercepts do I have?
Wait, sir, I have like a very random question.
What's
well,
up?
it's not random, but it's about this.
What's up?
So like, you know how sometimes like the lines that you just plotted can go like straight down, right?
Mhm.
Would that still be, because you see how you have them going outwards? Does it matter how they go? Like, can we draw them straight down or going outwards, or?
Yeah, I mean, you can draw them however, as long as they're all headed towards negative infinity, that's totally fine. It does have to be curvy though. I wouldn't just do something like, you know, like that.
Okay,
So,
thank you.
yeah. Okay. So how many x-intercepts do we have?
One.
One. That's it. One. And what is our domain? Again,
Negative, infinity, infinity.
good. And our range, since we open down, we have to start at negative infinity. And then we come up the y-axis and we stop at the y value of the vertex. What is our y value?
0.
0.
0. Yay. Cool. All right. Oh, and I think we actually did that last part down there. It says, find another point to plot using the y-intercept. Find its mirror image across the axis of symmetry. Boom. We did it right there already. Okay. Everybody good with that one? I guess I'll label the point. That point is -2, -1. Cool. All right. Not bad. Okay. Number 6. Okay. So -x squared plus 4x plus 3. What is the value of a?
-1.
-1, which means we open
So
down. Good. What's the value of b?
4.
4. Now let's find that vertex. H is -b over 2a. So you'll get -4 over 2 times -1, which gives me -4 over -2, which is 2. There's the H value of our vertex. And then K does f of 2. Plug it into the function above. -2 squared plus 4 times 2 plus 3. And that is -4 plus 8, which is 4. And 4 plus 3 gives me 7. There's our vertex. 2, 7, which means you have the axis of symmetry as well at x equals 2. Okay, now find the y-intercept. Just do that over here again. Let x equal 0. And if X is 0, again, that 0, what are we left with?
3.
3. Good. So we get 0, 3. Okay. Now we have enough information to plot this parabola. So let's put our vertex down. 2, 7. So out 2, up to 7, right there. There is our vertex. And then my y-intercept is at 0, 3, right there. There's my y-intercept. And then let's make it pretty. Let's find that other point, which means let's just reflect it across the axis of symmetry. So if this point is 2 spaces away, the other point reflected across will also be 2 spaces. Okay, beautiful. And connect. We open down. All right. And now, how many x-intercepts do we have?
2.
2. And once more, what is our domain?
Negative infinity.
And since this opens down, where do we start at for our range?
Negative infinity.
Good. We start negative infinity. And then we come up the number line and we stop at the y value of the vertex, which is
7.
7. There we go. And this would be a maximum. Oh yeah, the one above was a what, minimum? Or no, that was a max too. Okay, sweet. Everybody good with that one? Okay, cool. Let's do it again. Bigger numbers this time. All right. Negative 3x squared minus 30x minus 82. Okay, what is the value of A?
-3.
Negative 3, which means we open
Down.
down. Why all the negatives? Boo. What is the value of B?
-30.
Negative 30. All right. We got everything we need. Let's find H. H is negative B over 2A. And that's going to give me negative 30 over 2 times negative 3. That gives me positive 30 over negative 6, which gives me negative 5. There's the H value. Now, let's plug that in for K. K will be, oh, and it's G this time. Whatever, G or F, doesn't matter. G of negative 5, and you'll get negative 3 times negative 5 squared minus 30 times negative 5 minus 82. Oh man, big numbers. What is that? 25 times negative 3, that's negative 75. And negative 30 times negative 5 is positive 150. So negative 75 plus 150 is 75. And 75 minus 82. Is that negative 7?
Yes.
Yay. All right. Cool. There's our vertex. Negative 5, negative 7, axis of symmetry, negative 5. All right. Last thing to do is that y-intercept. Let x equal 0, f of 0. If you plug in 0, that's 0, that's 0, and what are we left with?
Negative 82.
Negative 82. Wow, that's no fun. 0, negative 82. Okay, cool. Now let's plot it. Vertex, negative 5. So there's negative 5, and there's negative 7. So negative 5, negative 7. There's our vertex. And then we know it goes down to negative 82. Look at that. Oh, yeah, somewhere out there, right? Negative 82. So I'll just put it down there just for fun. Why not? And then there's my axis of symmetry. And wherever that is, you can reflect it across. So we'll just say there's a random point out here. And then connect. Woo! All right. And do we touch the x-axis at all? No. So how many x-intercepts do we have?
0.
None, right? 0. Domain, negative infinity to infinity. What's my range? Where do we start?
Negative infinity.
And where do we stop?
Negative 7.
Very good. All right. Not bad. Oh, look at that. That's it. Okay. So that was graphing quadratic functions. That was the characteristics about parabolas and quadratic functions. Oh, yeah. And this one would be a max. Cool. Okay. That finishes those notes. So if you got questions, stick around. If not, see you on Wednesday.